Hey guys, my name is Sibusiso, also known as Coach Sbu. Welcome to the Maths Buddies channel. Here on this channel, I am dedicated to helping you solve math problems by providing you with solutions based upon your requests. So whether you are a new viewer or you are a returning one, if you find yourself with any math problem that you would like me to tackle, please don't hesitate to share that on the comment below so that I can be able to generate a video to help you with that solutions. So without wasting any further time, we're going to go straight into today's video. In this video, we're going to be talking about general trigonometry. I'll be providing you with methods to solve all these type of questions, which are, by the way, questions that you normally see or you normally find on your exams. So we're going to jump straight into the first question that we have here. So in this question, we'll be working with 5.1. So let's go ahead and read the question. If 5 cos A is equal to 2 root 6, where A is an element of 90 to 360, calculate without using a calculator and with the aid of a diagram the values in the simplest form. Alright, so now here in this type of question, basically what we're doing is we want to find the values of these questions, right? Using what? Using a diagram, with the aid of a diagram, right? Now, how do we do this diagram? So looking at the diagram or drawing a diagram, we need to take the information that we're given there. So here we are given that in this triangle that we're talking about, it has this info, that is 5 cos A is equal to 2 root 6, and it is located where the angle A is between 90 and 360. So now here the first thing that we need to do is to understand what this means, right? So here, if you are given this value like that, 5 cos A is equals to 2 root 6, the first thing that you need to do is you need to solve for this general trigonometry. So here we're going to solve for cos A. So by solving for cos A, we see that we're getting 2 root 6 over 5, right? But then now here, not only that, we can see that the answer that we get here is positive, right? So the first thing that you do is make sure that you solve for that trig ratio. As you can see here, that's cos A. Now the next thing is we can see that this answer is positive. So that's positive means that now we're going to ask ourselves which quadrant is this general trigonometry positive in, right? Now we know that cos is positive in the first quadrant and in the fourth quadrant, right? Now this is what we're going to need, right? Because we're trying to locate where this triangle is, right? Then now the second part, it said A is an element of 90 to 360, right? Now what does this mean? So this means now that this triangle is located where the angle is more than 90, right, but less than 360. So what are quadrants that are more than 90? So a quadrant that is more than 90, it is quadrant 2, right? All angles in quadrant 2 are going to be more than 90. Quadrant 3, all angles there are going to be more than 90, and then quadrant 4, they are also going to be more than 90 but less than 360, right? Now after locating these two, we're then going to ask ourselves which quadrant do we see in both statements, right? So here we can see here we see quadrant 4. Now this then means that our diagram that we're going to be using to calculate there is located in quadrant 4. Now I'm going to draw our quadrant like that, and I'm going to draw our triangle there in quadrant 4. There we go. So our angle is angle A, like that. Then now after this, now we need to fill in this triangle. Now to fill in this triangle, we're going to go back into this question that we got here, or this solution that we got here. Remember, we have cos there. Now we also known cos as adjacent over hypotenuse, right? So this means if now we say cos is adjacent over hypotenuse, then this will mean that here we're going to have our adjacent in this triangle is going to be 2 square root 6, and then our hypotenuse is going to be 5. Then as you can see here, we're going to need y. And then after this, we've done the first part. After this, we're going to go to Pythagoras. So Pythagoras to find the last side, right? So Pythagoras states that x squared plus y squared equals r squared, right? And then now here 2 root 6 squared, right, plus y squared is equals to 5 squared. Now if you square this one, if you press this on a calculator, it's going to be 2 root 6 squared, which gives you 24, plus y squared, this one is 25, and then you want to solve for y squared, so it's going to be 25 minus 24, then y squared is going to be 1, and then you're going to put square root both sides. Now whenever you're putting a square root in both sides in this type of question, always make sure that you leave your answer in plus minus 1. Why? Because here this plus minus, it tells us that this y value can either be positive or negative, right? It's either it's below or above the x-axis there, right? But then now here, as you can see in our diagram, this is below x-axis, therefore this means our y value is going to be minus 1. Then from here we're gonna then go into our question. So what was our question? So let me just hide this. Now our question was, we need to then find out what is going to be 5.1.1, what is the value of minus square root 6 times 10a. So the value for this will be equals to minus square root 6. Now here we're going to look at the diagram to ask what is 10a. Now 10, we know it is opposite over adjacent. Now opposite is going to be minus 1 because it's the angle facing, is the side that angle A is facing, which is minus 1. And then over adjacent, it is going to be our square root 6, right? Then as you can see here, negative times negative, this gives us basically positive square root 6 over 2 root 6, and then this cancels, leaving 1, and then answer is going to be 1 over 2. And then we're going to look at 5.1.2. 5.1.2 it says sine 2a, right? Now here this is a double angle, so we don't have a 2a there as our angle, we only have an a. So this means here we need to first apply the double angle as 2 sine a times cos a. And then here we can see that we have cos a and sine a. Now this then means that our sine a is going to be opposite of our hypotenuse. So my opposite is going to be minus 1, my hypotenuse is going to be 5, and then cos a is going to be adjacent to root 6 over hypotenuse, which is 5. Then from here we want to simplify into 2 times minus 1 times 2 root 6. It's going to be minus 4 root 6 over 5 times 5 is going to be 25. And that is going to be the answer that we get for the 5.1 question. Alright, so now let's go ahead and go into the next one. Now in the next one, we are given sine 18 is equals to p, right? Now this is also the same as this one, but here the difference is that in this one we have an angle, but then we don't have a side, right? If you remember in the previous one, we didn't have an angle, but we were told what were the sides, right? The actual value of the sides. But in this one we are told what is an actual angle, but then we're not told the side. Now first things first, question says without using a calculator we need to determine the following, right? Following questions in terms of p. Right, so now the first thing that we need to do, just like we did in the first question, we need to first locate our triangle. Now luckily here we told that our triangle is located where the angle, our angle is 18 degrees, right? So this means now we're gonna go straight first into our first quadrant. Now in this type of question, the idea here is that if an angle in the question is not located here, then we need to write it in a form that is going to be containing angles that are located in the triangle that we're going to be writing here. So first let's do this. You can see here 18, so we're told that this is 18, like that. And then now we're saying 18 is equals to p, but then now we know that sine is opposite of our hypotenuse, right? So if sine is opposite of our hypotenuse, this then means now our sine p is not just sine p, but it is sine p over 1. Then this gives us what? Our opposite being p and our hypotenuse being 1. So that's what we're going to do then here. Then we're going to say p, and we're going to say 1 there. Then now we'll need to find x. Now to find x, we're going to apply Pythagoras. Now again, x squared plus y squared is equals to r squared, and then x squared plus p squared is equals to 1. X squared is equals to 1 minus p squared. Put square root both sides, and then x is equals to plus minus square root 1 minus p squared. Then we can see our answer is above the x-axis, so it means we're going to take the positive 1 minus p squared. This means now that our x is going to be square root 1 minus p squared. Now with this one, if you remember, we have an angle here, right, which is 18. So because we have an 18 here, it then means now we also need to fill in everything in this triangle, because we don't know whether it might have pulse or not, right? So here I can say I have 18. Now I have 90 here, and then I need to fill in this angle also, right? So to do that, I'll just take 90 and minus this. I'll say 90 minus 18, and then it will give me that one, right? So 90 minus 18 should give me 72, like that. There we go. So yeah, now the idea here is that if in the question then we are asked to solve, for example, let's work on this one. So here they're saying this find cos 18, right? Now cos 18, the only way we can find cos 18 is if this angle here, right, is one of the angles that are in the diagram. As you can see here, 18 is there, so this means now cos 18 would then be, cos is adjacent of our hypotenuse, so cos is going to be square root 1 minus p squared, which is the adjacent over hypotenuse, which is 1. And then when simplified, this will be 1 minus p squared. Alright, now let's look at the second one. Now the second one here, we say 5.2.2. Now we're being asked to find cos 48, right? Now looking at this, we can see that cos 48 is not there, right? Now what we're going to do is we're going to go then into our calculator, right? So we're going to try to use all the terms that we know, right, to see if we can write 48 using these angles, right, or something else that we know, right? Now how are we going to do this? First of all, we're going to look at it as a double angle, right? So with a double angle, I'll need to check if I can take a number in our diagram, right, and then multiply it by 2 and then see if it's going to give me 48. As you can see, it doesn't, right? What about 72? 72, it doesn't, right? So because of both of them, they do not give us 48, I'll then leave the double angle out and then see what happens when I'm doing the compound angle. So compound angle will be when I'm subtracting them or adding them, right? So subtracting them, I'm getting 54. No, it doesn't work. Adding them, 90, doesn't work. Then now finally, what I'm going to do is I'm going to take a special angle, because both of them they didn't work, right? So a special angle will be, the smallest one will be 30. Then I'll first add it with 18 to see if I'm going to get 48, but if not, I'll subtract it. And then here, all right, there we go. As you can see here, when I'm taking 30 plus 18, I'm getting 48. So what is it that I'm trying to do here? I'm trying to have something that will contain an angle that is already there, right? And then now here I know what is a special angle, and I know that 18 is there. So this then means, because if I know both of these, I can then change 48 and write it as 30 plus 18. Now when you look at it this way, this is a compound angle, right? So this is going then to be cos 30 times cos 18 minus sine 30 times sine 18, right? Then now from here, I know that most of you guys, you don't press special angles on a calculator, but for me, I do, right? Because I mean, it's your calculator, you can press it. See here, square root 3 over 2. It doesn't matter, you would have gotten the same thing even if you were using the triangles, right? Square root 3 over 2. Then now cos 18 is there, so it means I can use that. So cos 18, I know that it is square root 1 minus p squared over 1 minus, now sine 30. What do? Press it on a calculator. Sine 30, I get 1 over 2, and then now lastly, sine 18 is opposite of a hypotenuse, so I know it's p over 1. Then from here, just multiply everything out. Alright, now square root 3 times square root 1 minus p squared, that will be square root 3 into 1 minus p squared, right? Now what did I do here? So here, this is a law of surds, right? So if you have a square root a times square root b, then this means they can both share one square root just as long as they're going to multiply each other. So that's what I did here. Over, now 2 times 1 is going to be 2, minus 1 times p is going to be p, 2 times 1 is going to be 2. Same denominator, so it means I'm going to add the numerators, right? So let's see. Square root 3 minus 3p squared minus p all divided by 2, because they both have the same denominator. Alright, so let's go ahead and look at the last one, 5.2.3. Now the 5.2.3 here, I can see that I want to find sine 9. Right? Now let's see. Now here, sine 9 is not here, right? So I'm asking myself 9. So if I take 9 and divide it by 2, see, I'm not getting any of those angles, right? Now I know you might have wanted to make a mistake. You might have wanted to say, no, but 18 is 9 times 2. No. Here our focus is not on there, it is on the angle 9, right? We need to manipulate it in such a way that it gives us, right, that angle there. Now with sine 9, we can see that this is a normal angle, right? Whatever that we do, we might not get any of the things that we have done already to get sine 9, right? Now what we're going to do here is, because of we don't have that, we're going to go into our double angle for cos, right? Now the double angle for cos are listed as follows, right? So I'm just going to write them here so that we can understand it. So the first one, right, we know that if we have cos 2 theta, of course the famous one, cos squared theta minus sine squared theta. Alright, now the second one says if we have cos 2 theta, right, then this is going to be 1 minus 2 sine squared theta, right? 2 sine squared theta. And then finally, if you have cos 2 theta, then I have 2 cos squared theta minus 1. Alright, so here what we're going to do is we're going to take this one here, right? We're going to take that one and we're going to manipulate that one. So we're going to, how are we going to do this? Here our angle here is 9. So basically this will then be, if we taking it, it is going to be cos, right? Now 2 times 9, because it's 2 theta there, so it's going to be 2 times 9 is equals to 1 minus 2 sine squared 9, right? So we're writing it aside there so that we can first understand what is happening. Now this is going to be cos 18 equals to 1 minus 2 sine squared 9, right? Then now here I need to solve for that sine squared 9, so I'll take the minus 2 over to get 2 sine squared 9, and then I'll take the cos 18 across to get a minus cos 18. Then from here I'll divide by 2 everywhere. So when I'm dividing by 2 everywhere, I'm getting sine squared 9 is equals to 1 over 2, right, minus cos 18 over 2. And then here when I'm putting the square root, I'm then getting sine 9 as square root 1 minus 2, square root 1 minus 2 minus cos 18 over 2. Alright, then this means now what I'm going to do here is I'm going to basically change my sine 9 into basically 1 over 2 minus cos 18 over 2. Now as you can see here in this new expression, we have cos 18, right? Now what is cos 18? We know cos 18 is square root 1 minus p squared. So you're going to say square root 1 over 2 minus square root 1 minus p squared over 2. And that is going to be our answer. Alright, so that is all for 5.1 and 5.2. Now let's go ahead and look at the question 6 type of question.